Hey everybody, this is Unit 5, Formative 3, Day 1. We're going to be simplifying radicals today. Okay, so when we simplify radicals, you're just going to be making a factor tree. So, in other words, a radical is just a square root, okay? Another name for it. And when we simplify them, you're making a factor tree. So, what we want to do is branch off of the 24 and find two numbers that multiply to be 24. You can pick any two numbers. So I think of 8 and 3 right away when I think of 24. Okay, and then 3 does not factor down any further, so that's at the end of the factor tree. So if it's 3 times 1, you just leave it as the way it is. 8, though, branches off into 4 times 2, and then 4 branches off into 2 times 2. Okay, so these guys all got branched down, so you can cross them off. You want to use the numbers that are at the end of the branches. Okay, so now you look for any pairs. Okay, well, you have a pair of 2's right here. Okay, so the 2's then, you're going to put any pairs that you have on the outside of the radical, and any leftovers. So in other words, this 2 and 3, you're going to multiply together, and that's what's going to go underneath the radical. Okay, if you had more than one pair left over, you would put that on the outside as well. Okay, you'd multiply it and put it on the outside. But in this case, there's only one pair of 2's, so we put one of those 2's on the outside, and you simplified the square root of 24. All right, let's look at another one here. We have 540, the square root of it. So we're going to take and break this down. Okay, we can take 54 times 10. There's obviously going to be more options than that, but this is the first one that I thought of. Then we can break down the 10 into 5 times 2, and that's as far as the 10 will break down, and 5 and 2 don't break down at all. 54 we could break down into 9 times 6. The 6 can break down, so the 54 broke down, we can cross it off. The 6 is going to break down into 2 times 3, and then 9 is going to break down into 3 times 3. So this is a pretty big factor tree. Yours may look different based on how you broke 540 down initially. But the next thing you're going to do is look for any pairs. Okay, well, we have a pair of 3's right here. Okay, we also have a pair of 2's right here. The 2's do not need to be on the same branch, or the 3's don't need to be on the same branch either. Okay, as long as you have a pair. So, your pairs you're going to multiply together. So we're going to take a 3 times a 2. So we take one of each. So a 3 times a 2. And that's what's going to go on the outside of your radical. So 6. On the inside then, okay, are your leftovers. So the leftovers go inside the fridge when you're done eating them. We're going to put the leftovers inside the radical. So we're going to multiply then the 5 times the 3 to get 15 underneath the radical. So 6 square root of 15 is what it would simplify down to. All right, this one here is a little bit different. Now we have variables in the mix. Okay, so first thing you want to do whenever you see variables is break this apart. So we're going to break it apart into the square root of 9 and the square root of x to the 6th. Okay, square root of 9 is actually a perfect square. It breaks down into 3 times 3. So you notice you just have a pair left. So square root of 9 just becomes a 3. Okay, some of you may already know the square root of 9 is 3, but that's another way to look at it. Okay, and then x to the 6th. The way that we do this is we look for how many times 2 will go into that exponent. Well, 2 goes into x to the 6th 3 times, so the square root of x to the 6th is just x to the 3rd. Okay, which means that x to the 6th is a perfect square because this is even right here. If this number was not even, then it would not be a perfect square, and we'll look at a situation like that in a little bit. So you put your two answers you got here and here together. So your final answer is just 3x to the 3rd power, and there's no radical. All right, and let's look at our last one here. So first we're going to break it apart into 3 sections. So we have square root of 54. We have the square root of a to the 7th. And then we have the square root of b to the 8th. So I broke it apart into 3 sections. Okay, square root of 54 we're going to do just like we're used to. So 9 times 6 gives you 54. 9 breaks into 3 times 3. Cross off the 9 because you broke it down. 6 breaks down into 2 times 3. So you have a pair of 3's So square root of 54 becomes a 3 on the outside. 2 times 3 gives you 6. So that is what square root of 54 breaks down into. A to the 7th, okay? So this guy right here is not even. So that means you need to break it apart. So you think, how many times does 2 go into 7? Well, 2 goes into 7 3 whole times. So that's going to give you a to the 3rd power. Okay, and then how many do you have left over when 2 goes in there 3 times? Well, there's 1 left over, so you're going to put an a underneath. Okay, so you have a cubed times the square root of a. So 2 went into 7 3 full times. That's where the a cubed came from. And there's 1 left over, so we put 1 underneath the square root. B to the 8th. How many times does 2 go into 8? Well, it goes in there 4 whole times. There's none left over. So the square root of b to the 8th just becomes b to the 4th. Okay, put everything together. So draw yourself a square root sign. The only things that are underneath the square root still are the 6 and the a. So we're going to put those there. And then we have a 3, an a cubed, and a b to the 4th all on the outside. And there is your answer. All right, and that is how you simplify a square root. Make sure you guys took notes, and we will see you later.